Hello student, good morning. I am Dr.A.K. Today I am going to start liquid state. Last class I finished gaseous state. Now I am going to start liquid state. Intermolecular forces are stronger in liquid state than in gaseous state. Molecules in liquids are so close that there is very little empty space between them, and under normal condition liquids are denser than gases. Molecules of liquids are held together by attractive intermolecular forces. Liquids have definite volume because molecules do not separate from each other. However, molecules of liquids can move past one another freely. Therefore, liquids can flow and can be poured and can assume the shape of the container in which these are stored. Okay, these are the simple things of the liquid. Already I have discussed earlier also. Now I am going to tell about the vapor pressure. Vapor pressure, this is very important. Vapor pressure. What is the vapor pressure? Just to understand. Just by example you can understand. Listen carefully. If an evacuated container is partially filled with a liquid, a portion of liquid evaporates to fill the remaining vapor of the container with vapor. Initially, the liquid evaporates and pressure exerted by vapors on the walls of the container, that is actually called vapor pressure. Again you listen that if an evacuated container is partially filled with a liquid, a portion of liquid evaporates to fill the remaining volume of the container with vapor. Initially, the liquid evaporates and pressure exerted by vapors on the walls of the container increase. Okay, that is the vapor pressure increases. After some time, it becomes constant. An equilibrium is established between liquid phase and vapor phase. Means a liquid will evaporate, it will fill the full container. Then this vapor will create pressure on walls as well as on the surface of liquid. Okay, this is the important this. Then this pressure due to vapor, that is called vapor pressure, and it will exert on the surface of liquid. After some time, if you will see one container we are talking, after some times it becomes constant. An equilibrium is established between liquid phase and vapor phase. Vapor pressure at this stage is known as equilibrium vapor pressure or saturated vapor pressure, because liquid evaporated and filled the full container. Now no place, it is filled with vapor only. That's why it is called saturated or equilibrium, because vapor will convert to liquid, liquid will convert to vapor. That's why it is called equilibrium vapor pressure or saturated vapor pressure. Since process of evaporation is temperature dependent, the temperature must be mentioned while reporting the vapor pressure of a liquid. we must write the temperature also. At what temperature, how much vapor was there. See, in evaporation takes place every minute, every second you can tell. If water is there, liquid water is there, then evaporation takes place every minute or every second you can tell. But rate of evaporation depends upon the temperature. In summer, rate of evaporation will be very high. Quickly it will evaporate. In winter, it will be medium. And in rainy season, it will be very slow. That's why wet cloth will not dry, because rate of evaporation is very slow. Already this in atmosphere water is there, water vapor is present, then they will not absorb vapor. That's why this wet cloth will not dry fast. It will take too much time. But in winter, it is a middle between the winter, rainy season and summer. Summer is the highest. Water evaporates very fast. Rate of evaporation will be very fast. Then this is happening because of temperature dependence. Then that's why temperature has a role here. And after that I will tell you that in boiling same things happens. When water you boil, then when you are not heating, that time evaporation will be normal way. But if you begin to heat it slowly and slowly, then water, more and more water will evaporate, and they will create more and more water will convert into the vapor, and it will be on the surface of water, and they will create pressure. And if you will cover the container, with the dish, then what will happen? All vapor will be inside only. Then and you are heating, then more and more vapor will be there. It will create more and more vapor. And that vapor will create pressure on the surface. And when this vapor pressure will be more and more, then what will happen? That when this vapor pressure will become more and more and will become equal to atmospheric pressure, then water will boil. Then that time, what was the temperature? At what the temperature at which vapor pressure becomes equal to atmospheric pressure, that temperature is called boiling point. What is the boiling point? Understood? I think so. The temperature at which vapor pressure becomes equal to the atmospheric pressure, that temperature is called boiling point. Okay, this is very important concept I told you. And that time only, at that temperature only, liquid will boil. Okay, I have briefed you. When a liquid is heated in an open vessel, the liquid vaporizes from the surface at the temperature at which vapor pressure of the liquid becomes equal to the external pressure. Evaporation can occur throughout the bulk of the liquid, and vapors expand freely into its surrounding. The condition of free evaporation throughout the liquid is called boiling. The temperature at which vapor pressure of liquid is equal to the external pressure is called boiling temperature or boiling point. Boiling temperature at that pressure. Vapor pressure of, I will tell you about the some vapor pressure of some liquid I will tell you. Okay. Then Here again you should understand at 1 atmospheric pressure, boiling temperature is called normal boiling point. This question is asked, that's why I am repeating. 1 atmospheric pressure boiling, 1 atmospheric pressure boiling temperature is called normal boiling point. If pressure is 1 bar, if pressure is 1 bar, then the boiling point is called standard boiling point. Then normal boiling point for than 1 atmospheric pressure you are considering, and 1 bar you are considering for standard boiling point of the liquid. A standard boiling point of the liquid is slightly lower than the normal boiling point because 1 bar pressure is slightly less than 1 atmospheric pressure. This you keep in mind. The normal boiling point of water is 100 degrees centigrade, means 373 Kelvin. Its standard boiling point is 99.6 degree centigrade, means 372.6 Kelvin. In IIT, this type of question is asked. Okay, 99.6, just why 100 degree you are always remembering boiling point of water, but if it is STP, a standard temperature, a standard boiling point, that time this will be 99.6 degree Celsius. Okay, this is very, very important things. I have told you when pressure is 1 bar, that time boiling point of water is 99.6 degrees centigrade. At high altitude, means on mountain you can tell. At high altitude, atmospheric pressure is low. Therefore, liquids at high altitude boil at lower temperature because pressure is low, hence it will boil soon. Therefore, liquids at high altitude boils at lower temperature in comparison to that at sea level. Since water boils at low temperature on hills, the pressure cooker is used for cooking food. In hospital, surgical instruments are sterilized in autoclaves. Always sterilization is done in autoclave, in which boiling point of water is increased. Boiling point of water is increased by increasing the pressure because they require high temperature. That's why they will, by increasing pressure above the atmospheric pressure, they will increase. Then they will get high boiling point and instrument will be sterilized, and this is done in instrument name is autoclaves. Question is asked. Okay, the atmospheric pressure by utilizing a what cover there will use wetless cover. Atmospheric pressure is by using a wet covering the vent, that generally wetless cover they will use. Okay, boiling does not occur when liquid is heated in a closed vessel. On heating continuously, vapor pressure increases. At first, a clear boundary is visible. You have seen in kitchen also, when water is boiling, then you can see that now two things you will see. Clear cut boundary you can observe, one vapor boundary and other liquid boundary. Means liquid and vapor both you can observe that, okay, this is the liquid, this is the vapor. On heating continuously, vapor pressure increases. At first, a clear boundary is visible between liquid and vapor phase because liquid is more dense than vapor. As the temperature increases, more and more molecules go to vapor phase and density of vapors rises. At the same time, liquid becomes less dense. It expands because molecules move apart. When density of liquid and vapors becomes the same, is important things. When density of liquid and vapors becomes the same, the clear boundary between liquid and vapors disappears. This temperature is called critical temperature. Already I have discussed. This boundary, when it will disappear, then that temperature is called critical temperature. Means when density of liquid and vapor becomes the same, both density, vapor density and liquid density, both become the same, the clear boundary between the liquids and vapors disappears. Means same phase, both will become same phase. Then the temperature at which this happens is called critical temperature. Now I am going to tell about the very important terms, surface tension. But here one graph I will send, then you will understand again very clearly. That graph is vapor pressure versus temperature. Vapor pressure versus temperature. Then you can see that how you can say at different temperature vapor pressures are different. Vapor pressures are different at different temperature. That you can understand. In video I will try to send it. Now come to the surface tension. This surface tension is a very important term, and many question is asked based on surface tension. I am telling about the surface tension. It is well known that the liquids assume the shape of the container. Why is it then small drops of mercury Hg, form a spherical bead instead of spreading on the surface? Generally liquids will spread, but mercury will not spread. Drop of mercury forms a spherical bead instead of spreading on the surface. Why do particles of soil particle also some things happen? Listen, why do particles, this is a question, why do particles of soil at the bottom of river contain particles of soil at the bottom of river remain separated, but they stick together when taken out? Why does it happen? Then other question is also there. Why does a liquid rise or fall in a thin capillary as soon as the capillary touches the surface of the liquid? Then these are the questions you can answer only by concept of surface tension. All these phenomena are caused due to the characteristic property of liquid. Surface tension is a special property. Special property is also called characteristics property of the liquids, called surface tension. A molecule in the bulk of the liquid experience equal intermolecular forces from all sides. If suppose in a beaker you have taken water and you are considering molecule in the middle. In the water molecules, in the middle you are considering any water molecule. Yeah, suppose half you have taken half filled water in a beaker. Then you will see in the middle of water any one point you consider. Then suppose point A is there, you are considering one water molecule. Then on that water molecule, from each direction force will be acted. East, north side, east side, west side, south side, every side, from the every side intermolecular force will be acting on that molecule of water A. Suppose water molecule we are considering. Then all, because equal forces are acting from each direction, hence they will cancel, and that water molecule A will not feel that any forces are acting on it. But if you are considering water molecules of surface, water molecules at surface, then there what will happen, that only from the inner water molecules they will attract. Upper, no water molecule is there. Above the surface of water, no water molecules are there, but down water molecules are there. Then only these water molecules are attracting surface molecules of water. That's why forces will be acting towards down only, inside the water, not upside. Upside no water molecules. Hence forces will be more inside, towards inside. These things you keep in mind, then you will understand these things, surface tension, very quickly. Then inside more forces, outside no forces. Only little forces due to the air, but not due to the water molecules. Then these water surface molecules of the water surface will be in tension. Okay, because inside only forces are working, outside no forces are working. This you have to consider. Then what will happen? Liquid, in that situation, that the molecules on the surface of liquids, net attractive force is towards the interior of the liquid due to the molecules below it, since there are no molecules above it. Liquids tend to minimize their surface automatically, because upside no forces are there, only inside forces are there. Then liquids tend to minimize their surface, because no forces are there, only inside forces are there. Hence liquids tend to minimize their surface area. The molecules on the surface experience a net downward force, and hence more energy than the molecules of the bulk. Upside more energy will be there, and in the bulk comparatively upside more energy will be there, because they are in tension. They want to minimize surface area, hence upside more energy will be there. The molecules on the surface experience a net downward force and have more energy than the molecules in the bulk, which do not experience any net force. Therefore, liquids tend to have minimum number of molecules at their surface. If the surface of the liquid is increased by pulling a molecules from the bulk, attractive forces will have to overcome. This is important point, because upside forces, kinetic energies are more and forces are less. Comparatively no forces, very less. negligible. That is also due to the air. Then if surface of the liquids is increased because surface is a less upside. Then if surface of the liquid is increased by pulling a molecules from the bulk, they will, because upside molecules are less, surface is less, hence they will try to bring molecules from the down, from the bulk. Then if surface of the liquid is increased by pulling a molecules from the bulk, attractive forces will have to overcome. Then this will require a expenditure of energy, because they want to bring molecules from the down to up. Hence, they will require more energy. The energy required to increase the surface area. The energy required to increase the surface area of the liquid by 1 unit is defined as surface energy. What is the surface energy? The energy required to increase the surface area of the liquid by 1 unit is defined as surface energy. The dimension of surface energy is joule per meter square. Joule per meter square. Okay, means meter minus 2. Joule meter minus 2 or joule per meter square. Surface tension is defined as the force acting per unit length. Very simple definition. Surface tension is defined as the force acting per unit length perpendicular in the line drawn on the surface. Very simple definition is there. Surface tension is defined as the force acting per unit length perpendicular upside perpendicular to the line drawn on the surface of liquid. It is denoted by Greek letter gamma. It has dimension of kg per second square. Kg, its dimension is kg divided by second square. That is the kg second minus 2. Second power minus 2. And its SI unit is, in SI unit it is expressed as Newton per meter. This unit is asked in examination. Newton, capital N, Newton per meter, or also you can write Newton meter minus 1, meter power minus 1. The lowest energy state of the liquid will be when, again you listen, important thing, the lowest energy state of the liquid will be what surface area is when surface area is minimum. The lowest energy state of the liquid will be when surface area is minimum. Surface area will be minimum, that time energy will be lowest. That's why liquid want to become surface area, they want to reduce. Okay, because energy will be less. The lowest energy state of the liquid will be when surface area is minimum. A spherical shape satisfies this condition. That is why mercury drops are spherical in shape. This is the reason. You got the answer. Because the lowest energy state of they want to reduce the energy. The lowest energy state of the liquid will be when surface area is minimum. Then when will be the minimum? Then when it will be in the spherical shape. Then a spherical shape satisfies this condition. That is why mercury drops are spherical in shape. This is the reason that sharp glass edge are heated for making them smooth, because again their surface area will be surface will have a less energy, means spherical, somewhat spherical. Corner will be not pointed, it will be spherical, somewhat sphere. This is the reason that sharp glass edges are heated for making them smooth. On heating, the glass melts and the surface of the liquid tends to take the rounded shape at the edge, which makes the edge smooth. This is called the polishing of glass. This is also called the polishing of glass. Liquid tends to rise, again another important point. Liquid tends to rise or fall in the capillary. Why? Answer you understand. Liquid tends to rise or falls in the capillary because of surface tension. Because they want to bring molecules from the down to up. That's why. Then liquid tends to rise or fall in the capillary because of surface tension. Liquids weight the things because they spread across their surface as thin film. They want to spread, that's why it is coming up. Liquids weight the things because they spread across their surface as thin film. That's why towel also, when you will put in water, towel, one end you will put in water, then some water will come up. Some water will come up due to the surface tension. And also walls. If down water is there, any wall, house I am talking about in rainy season, if down suppose half feet water was there in the home, then it will go up on the wall. That also because it is spreading, it is going up due to the surface tension. These things you might have observed also. This happens. Then now other things you can see, I told most soil grains, most soil in a river I am talking about, inside the river, most soil grains are pulled together when water will be not there, or if you will bring that soil outside, then all soil grains will touch to each other, they will come together. Most soil grains are pulled together because surface area of thin film of water is reduced. Surface area will reduced, that's why they are coming close. Okay. Then this I have told you about the this soil grain. Why soil grains comes close to each other? If we bring it outside, then this happens due to the surface tension. Moist soil grains are pulled together because surface area of thin film of water is reduced. It is a surface tension which gives a stretching property to the surface of liquid. Okay, in a simple way you can understand also. It is a surface tension which gives a stretching property to the surface of a liquid. That's why it becomes spherical. On flat surface, droplets are slightly flattened. On flat surface, droplets are slightly flattened by the effect of gravity. But in the gravity free environments, drops are perfectly spherical. If there will be no gravity, then that time droplet will be fully spherical. But they are on the surface you will put some water drop, that it will spread, it will be flattened, it will be not spherical because of gravitational force. But if there is no gravitational force, then it will be full spherical. The magnitude of surface tension of a liquid depends upon attractive forces between the molecules. Again, important things. This I told you. The magnitude of surface tension of a liquid depends on the surface forces between the molecules. When the attractive forces are large, the surface tension is large. Okay. Increase in temperature increases the kinetic energy of the molecules, and effectiveness of the intermolecular attraction decreases. Here, very important things. When the attractive forces are large, the surface tension is large. First things. Now, second things, increase in temperature. If you increase, then what will happen? If you increase the temperature, increase in temperature increases the kinetic energy of the molecules. Then molecules will move fast, and effectiveness of intermolecular attraction decreases. That time, if temperature will increase, then attractive forces will decrease. When attractive forces will decrease, then molecules will move. So surface tension decreases. Means if you increase the temperature, surface tension will decrease. Surface tension decreases as the temperature is increases or raised. This I have told about the, you can say, surface tension. Now I am stopping only here. Next class again we will meet. Thank you.